The survival of the Netherlands has always depended on controlling water.
The Netherlands, they live with water.
The Netherlands is 15 times smaller than France. The country is bordered by the North Sea along 450 kilometers of coastline. 2/3 of the country are prone to flooding, and more than half is below sea level.
Even here, in the center of Amsterdam, I'm sitting here now below sea level.
To extend their territory, the Dutch have erected 22,500 kilometers of dikes between them and the water, equivalent to the length of the Great Wall of China. The most amazing example of these barriers is the ring-shaped Randstad dike, which protects Holland's 3 biggest cities, including Amsterdam.
Despite the sophistication of the system, everything in Amsterdam is constantly being monitored.
For the past few years, the city of Amsterdam and the country as a whole have been facing an even greater and more unpredictable danger: global warming and rising sea levels.
If you know that you want to change Holland and you want to live with the water, we have to come up with new technologies. And Dutch are innovative.
2 Dutch scientists have now come up with a crazy project for a North Sea wall. It is a cry for help to the rest of the world. This double dam would close the North Sea in 2 places to prevent the Netherlands from being swallowed up.
It's very difficult to say by how much and when the water will rise, but you have to be prepared for the worst.
The Dutch have been able to stay safe thanks to a veritable military arsenal. It includes the Maaslandkering, the largest dam in the world, the Oosterschedelkering, each gate of which weighs more than 480 tons, the equivalent to 2 A380 aircraft, enabling it to withstand the power of the North Sea, and the Zaan motor, which spews out tons of sand every day to reinforce the dunes. The technological prowess of these superstructures is unparalleled.
People at the water board, they can manage to bring water up and down. Same if you're a DJ, you can also tune the music. So the challenge is how to keep your water level always stable.
Since the Middle Ages, Amsterdam, the historic capital of the Netherlands, has showcased some of the strongest and innovative constructions, such as houses built on stilts. But the world's most advanced flood control weaponry is never completely immune to failure.
If it happens, then it will be, a real disaster.
But will Dutch innovations be enough to avoid it? Amsterdam, the historic capital of the Netherlands with its legendary canals, is located in a delta where sea and rivers meet. It is one of Europe's most threatened cities when it comes to rising water levels. Protecting itself from the risk of flooding is an imperative for this country, which has more than a quarter of its territory below sea level, and Amsterdam in particular. As incredible as it may seem, the center of Amsterdam is located 4 meters below sea level, while Schiphol International Airport is 6 meters below. The airport and the city only exist thanks to the dikes that surround them.
We have mounds of earth connected by dikes, upon which construction has taken place. These mounds can be relatively small, the size of a village, or much larger, home to a big city.
A dike is a man-made barrier used to regulate or hold back the surrounding water. Far from what one might think, dikes in the Netherlands are like land bases on which entire cities have been built, with streets, railway stations, and motorways. In this country, where 2/3 of the territory are below sea level, it is imperative to build on stable, raised ground. Over the centuries, a tangle of dikes has entirely shaped the territory, protecting it from water. As such, the country's three largest cities, Amsterdam, Rotterdam, and The Hague, are linked by a circular dike called the Randstad. This dike, invisible to the naked eye, is in the shape of a ring. This shape makes it much more robust than a dike in a straight line. Today, some 7 million people live within this ring. The economic heart of the European Union's fifth biggest economy is protected by this circular dike.
Here we are in Rotterdam, and we are on the dike. The main dike begins under the central station in Amsterdam.
The central station sits on this ring dike that starts in Amsterdam.
Here in Rotterdam, we are on the southern dike of this polder.
The dikes are the result of work carried out over centuries, and the Dutch are proud to have built their country from scratch. Plot after plot, now almost a quarter of the country's territory has been reclaimed from the sea.
The country I live in, Holland, is not a real country, but it's a fake country. It's artificial, it's man-made.
Since the early Middle Ages, the Dutch have defied nature and built an entire country on water and swamp. The most fascinating example of this battle won with the water is the city of Amsterdam. Amsterdam takes its name from the Dutch word dam, meaning dike, and the Amstel, the river that flows through it. Once a humble fishing village in the 17th century, Amsterdam became the most prosperous port in Northern Europe. The city, which was made famous by its canals, owes its prosperity to the water that serves as a route for trade. But above all, it is down to the ingenuity of its people. These canals are like knife cuts notched into the dike that forms its foundations. They allow the water to circulate. Amsterdam's canals stretch for a total of more than 100 kilometers, crossed by some 1,500 bridges that link around 90 islands. Amsterdam's canals form what is known as the Golden Curve, which gave rise to the city's nickname, the Venice of the North.
The city was built on a dike, which is like a mound of earth. Then you build on top of it and create canals all around to enable traffic to flow and to prevent flooding.
So what does that mean? That means that there somewhere is a levee, maybe 2 or 3 meters, and that behind there's a canal, and we're still pumping groundwater into that canal, from the canal to the river and from the river to the sea.
The Dutch have always known how to transform their dangerous geographical situation between sea and river into an asset for trade, because they use the water to transport their goods. But to meet demand, they needed additional land for livestock. So in 1320, they built a circular dike that would allow them to extend their territory. Furthermore, creating meadows around Amsterdam would protect the city from the risk of flooding. This very first flood protection construction is a real achievement. Although no longer visible, this 126-kilometer-long dike was built at more than 5 meters above sea level and protected an area of around 800 square kilometers, including the city of Amsterdam, an area the size of the city of New York. It is thanks to this artificially created land that the Netherlands has been able to expand and to protect its historic capital. For centuries, the city of Amsterdam has therefore been the object of much attention. Thanks to the circular dike and some constant surveillance, the Dutch have so far been able to avoid the city being flooded. But sometimes it's been a close-run thing. On the night of the 13th of January 1916, flooding rivers and high tides led to dozens of dikes being breached. The entire region around Amsterdam was flooded. But miraculously, the capital was spared. The horror at the idea of seeing this historical treasure being devastated by floods pushed the Dutch authorities to take action that transformed their territory forever. They decided to close off the North Sea inlet on the edge of which Amsterdam was built.
So it was decided to close off this branch of the North Sea. The Southern Sea was closed off by a dike, and it was then the largest dike in the world.
A huge construction project was undertaken to build this gigantic dike, 32 kilometers long and more than 7 meters high, cutting right through the North Sea. The Afsluit dike, also known as the Enclosure Dam, was a technological feat for its time. This unique project confirmed the Dutch as world leaders in anti-flood technology. The dam took more than 20 years to complete. Tons of clay, concrete, and scrap metal were required to create this enclosure dam, which came down like a guillotine in the open sea. The first mission for this construction was to protect Amsterdam and its 210,000 inhabitants at the time from the risk of high tides.
Amsterdam, like all of the rest of the country, and certainly the low-lying parts, is protected by the dikes from flooding from the sea. There are smaller dikes also protecting it from the central lakes in the center of our part. So this is the basic safety that any city in the Netherlands has. So Amsterdam is part of that bigger infrastructure.
Since 1932, thanks to the Afsluit dike, Amsterdam has been the best protected city in the Netherlands. Reassured, the Dutch then tried their luck by expanding even more. And to do this, they used a technique that dates back to antiquity: polderisation. Since the 16th century, the Netherlands has expanded its territory by some 8,000 square kilometers, an area around the size of Corsica.
We've always been threatened by water, by sea, by rivers, and we have defined a kind of mechanical, a kind of machine, what Holland is, an artificial country, where we can beat the water. We push the water out and we create a dry land.
Around 1/5 of the country is built on land reclaimed from the sea and the marshes. This reclamation is known as polderisation. The Romans used these techniques back in the 1st century. To polderize an area, it must first be dried out. To do this, it is surrounded by a dike. Then, with the help of windmills and now electric pumps, the water contained within the area is pumped out through canals. The water leaves behind muddy areas in which reeds or other plants are added to absorb the salt and complete the drying and desalination process. This marine land is thus transformed into arable land.
The decision to create these polders was connected actually by the projections of the demographics of the country, as well as the necessity to become independent in agricultural terms, to be self-sufficient agriculturally. So we needed new land, and we were very successful in doing so.
There are fields as far as the eye can see, covered with green grass. But behind this image of nature, each plot of land here is artificial. Under these carpets of grass, the earth lacks fertility.
Human beings have an amazing capacity to disrupt, but also to degrade and destroy entire ecosystems. You have to accept that in spite of our eco-engineering feats, no matter what we do, we'll probably never be able to create anything 100% natural.
Creating something 100% natural a fantasy? Not for the Dutch. The most incredible example of this artificial nature is the creation of Flavorland, an entire province in the suburbs of Amsterdam that is the same size as Luxembourg. Flavorland was created in 1986. It was a huge project that had been under consideration for decades and which met the Netherlands' constant need for more land for agriculture.
Between 1914 and 1918, there was a famine due to the First World War. This project came about to provide agricultural land.
This crazy project would never have seen the light of day without the Enclosure Dam, completed in 1932. The dam created a lake, which allowed the Dutch to polderize areas of fresh water and thus create new land. But this reclaimed land is particularly vulnerable to flooding, and its inhabitants must live with that threat. The province of Flavorland is located at between 6 and 14 meters below sea level. The soil is fragile, and constant tides in the rivers make the risk of flooding a little greater every day.
Paradoxically, the cities most at risk are not exposed to the sea, but further inland. And then a city very much at risk is Lelystad, that actually is in a deep polder, in an area that used to be part of the sea, but now is an inner lake thanks to a closure with a 30-kilometer long dike.
Lelystad is just 60 kilometers from Amsterdam, and the historic capital and the new city have something in common: the fragility of the soil. Amsterdam is located on swampy soil composed of soft peat and clay. This soil is a real challenge for architects. As far back as the 17th century, they had to find a way to make the foundations of the houses, designed in the typical Flemish style, hold firm in the ground. All buildings in Amsterdam are built on piles with wooden stakes. But to reach the first stable layer of solid sand, it was necessary to drill down to a depth of more than 11 meters, the equivalent of a 4-story building.
So every house you see, you have the house, you have the stilts underneath it, is put on stilts. And for example, if you go to the center of Amsterdam, there's a big palace. And underneath that palace, there is, I think, 13,000 piles of 20 meters holding up one building. So the most dense forest of Holland is underneath one building.
This underwater forest supports houses built on cob, a mixture of clay and straw. Designed to be submerged, this traditional material is very robust as long as it is not exposed to variations between air and water. But in recent years, traditional Amsterdam homes have been facing a new challenge brought about by global warming. This time, it is no longer flooding that threatens them. It's drought, which poses a danger to their foundations. This is a new phenomenon for this northern European capital. In recent years, the city has experienced long periods of drought and heat that make the water levels in the canals fall, exposing the cob to the open air, making it dry out and crumble. Then, when the water rises during the winter, it seeps in and eats away at the foundations. The historic center of Amsterdam is now facing a new risk, that of collapse.
Holland is artificial, it's fake, and the people at the waterboard, they can manage to bring water up and down. Same if you're a DJ, you can also tune the music and make the rhythm and the sound and the light go out. That's how we also work with Holland. So if we have water storage areas, then if there's too much water, we bring the water to the water storage area, and by that the water level in Amsterdam stays the same. If there's a lot of dry, we bring water from the water storage areas back into the water. So then still we have the same level. So the challenge is how to keep your water level always stable.
Controlling the water, monitoring the level, and keeping it at a distance so it doesn't engulf the country. The Dutch have been fighting against water for centuries. But there is one danger that nobody can be fully protected against: storms. Winters in the Netherlands always bring storms. The combination of very high winds and the North Sea at its highest level brings a real threat of flooding. The fear of seeing waves of icy, muddy water breaking on the coast is in everyone's minds. Every year, behind the dikes, they prepare themselves for the worst. And the worst happened to the Dutch on the night of the 31st of January, 1953. During this terrifying night, the province of Zeeland on the southern coast of the North Sea was battered by one of the most terrible storms Europe has ever seen. A combination of 160 kilometers an hour winds, excessively high tides, and a powerful depression from the northwest sent the water up to an exceptional height.
Mankind has accomplished some absolutely incredible technical and technological feats. And we forget, when we talk about water, that water is so much more powerful.
You cannot tell it enough how the power is of the water, and you should be afraid of that.
Water shapes entire valleys and erodes everything in its path when it wants to. No matter how much technology you bring to it, it will always find a way. So it's up to you in the end not to get in its way.
The phenomenon of coastal flooding begins away from the coast. Tons of water are lifted up by gusts of wind to crash down on inhabited land. Because the Netherlands are located in a delta where rivers meet the sea, they are extremely vulnerable.
So if you think of the map of the North Sea and the wind from the north, you see that it goes into a funnel. So the water levels are pushed up, and this can lead to water levels that are 4 meters higher than the average sea level.
The wind drove a huge amount of water inland, and the water rose in the houses with incredible speed.
The water came so high that my father decided we should go on top of the roof. We know people who have saved their lives. They put out the tiles of the roof, and on the wooden construction, they were floating.
In the early morning of the 1st of February 1953, the storm-stricken region of Zeeland woke up to utter devastation. The disastrous consequences of this high tide traumatized the entire country. There were more than 1,800 dead, 100,000 homeless, and 160,000 hectares of land flooded. Once again, Amsterdam was spared, but the country was forever marked. Despite the fact that these events were caused by natural phenomena, the consequences of the high water were linked to human construction. The Netherlands' ingenious network of dikes, built up over the years, broke in 89 places.
The important thing to understand is that protection is never total.
But if the Netherlands can never be totally protected, to what extent can Amsterdam be saved? After the Great Storm of 1953, the Dutch had no choice. They declared war on water. To wage this war, they set out a military strategy known as the Delta Plan. This plan described all the major works to be carried out to block the path of the water.
The fight against water is perhaps one of the major themes in the collective image that we have of the Netherlands.
Their main weapons were barrages, dams of unrivaled power and dikes that were stronger and higher than ever seen before. At every point of entry, the water would come up against the military force of these superstructures. The safety of the 18 million Dutch people who live behind them depends on it.
The most important thing was to be able to live here. First, they built the dikes to protect the fields, then they built the dikes to protect the people who lived behind them. So in 1953, they thought it was normal to spend up to 3% of GDP on these major projects.
This defense strategy took full effect in Zeeland, the region devastated by the storm of 1953. Seen from the sky, it looks like lace. The water is everywhere. To defend themselves against it, the Dutch erected some impressive dams. In 1979, a huge construction of earth and steel was created. The Oosterschedelkering, or the Eastern Scheldt Storm Surge Barrier, was the first superstructure to be built after the storm of 1953. It took 26 years for this unprecedented technological innovation to see the light of day. This 9-kilometer-long barrage, located between two islands, has 62 steel sliding doors, each weighing 480 tons. These 62 barriers, which separate the North Sea from the Eastern Scheldt River, have come down 27 times since the barrier went into operation. Each of the doors weighs the same as 15 heavy trucks, and they are lowered as soon as the swell exceeds 3 meters. On 27 occasions, they have fended off coastal surges like that seen in 1953.
It has protected our country from floods from the sea already for 2 generations. And so it will remain a very essential part of our flood defense strategy.
Once the south of the country was secured, this extraordinary plan to protect the country then turned to Amsterdam's big sister, Rotterdam, the country's economic capital. The biggest port in Europe, 80% of the city of Rotterdam is located below sea level. Rotterdam may have made its fortune from water, but at the same time, it risks perishing from it too. In the north and in the south, everywhere the water could come in had to be blocked to prevent flooding. The rivers are the enemy to be fought. And the first defense is the Haringvliet, a spectacular construction that regulates the waters of the Meuse and the Rhine, the 2 rivers that flow through Rotterdam. As soon as the water level gets too high and threatens to flood the city, the 17 openings in this dam are activated and the river water is dispatched into the North Sea. This 5-kilometer-long dam also serves as a 4-lane motorway.
The budget given over to this project and the money still granted to maintain it are quite phenomenal.
Since its implementation, the Delta Plan has served as a military strategy, constantly pushing the technological limits. And its centerpiece is the most prodigious superstructure ever seen in the world. The Maaslandkering, built in the 1990s. Its purpose is to protect the city from storms. Located at the entrance to the port of Rotterdam, this mobile dam protects more than 3.5 million inhabitants, along with the commercial activity of the 8th largest port in the world. This hydraulic structure was completed in 1997, and is the largest mobile structure in the world at 420 metres long, the equivalent to the length of 4 soccer fields end to end, and 20 metres high. Its designers have planned for all eventualities. To prevent such a system from breaking in the event of a major storm, they left a slight opening between the doors when they close. This breach prevents the dam from breaking when water flows in hard and fast.
So about 3 meters or 3 meters 50 above the mean sea level, and a storm surge with a certain force, wind force 11 or 12, then it is decided to close the dam.
Twice, this unrivaled example of technological prowess has proven its effectiveness. During the storm of November 2007 and the North Sea storm in January 2018, water levels reached record levels. The authorities decided to close the dam and managed to avoid the worst.
For the people living over there at around 3.2 meters above sea level, it's very important for the dam to close in time to avoid their houses being flooded.
For Europe's largest port and the country's largest city, the daily challenge is to keep the threat as far away as possible. In order to ensure the greatest possible protection from the water, the Maaslandkering has a partner construction with which it works in tandem. The Hartelkering barrier is located a little further inland. It works like a guillotine and wasn't included in the Delta Plan. But since the 1990s, climate predictions have made it indispensable. This impressive 98-metre-long mobile dike is mounted on 3 pillars. Each of its doors is suspended at a height of 14 metres above the canal, comparable to a 5-storey building. Since 1997, the closing system has been used twice, simultaneously with the Maaslandkering barrier.
But this is a very gradual process, and we monitor this very closely, how this will evolve, because safety first.
Today, the Netherlands seem to be fully protected by its anti-flood weaponry. Just like Amsterdam, it is permanently monitored to keep the threat at bay. But behind their incredible technological prowess, the Dutch live with danger every day.
They have profoundly transformed their territory, and it is very tightly controlled. The aim is to have total control over the entire system, which no longer has anything natural about it. As such, we're not looking at a natural disaster. Rather, we're looking at a system failure that is due to this vision of having total control over nature.
In this artificial country, nature is like a machine in which humans control every cog.
And living in a machine like Holland means that you have to upgrade your machine every 30, 40, 50 years. 50 years ago, we thought that we were finished for the next 500 years. And now we know that we have to upgrade it, that the levees that we have, the polders that we have, are not enough to keep Holland dry for the next century.
Innovation and ingenuity can never stop here because there are so many dangers facing the Netherlands. In addition to rising water levels, river floods and storms, another major problem that is nibbling away at the Netherlands is one of coastal erosion. This is one of the first consequences of rising sea levels. The dunes subside and then disappear, and the disappearance of these mountains of sand is endangering the land behind the coast. Indeed, the dunes are the first line of protection against high waters. They act as natural ramparts. Without them, flooding would be unavoidable. And the Dutch have come up with a unique kind of vessel to reinforce them, the Zand motor. The idea is simple. Sand is gathered from the seabed and then sprayed in a continuous stream back onto the coast. This strengthens the coastal dunes, which then protect the rest of the country. What makes the sand motor so unique is that it uses the energy of ocean currents to bring the sand to the dune and the natural movement of the tides to stabilize it. This amazing system, which is based on natural processes, does, however, have certain consequences for the environment.
It dredges the sand from the ocean floor, but the ocean floor is basin-shaped. So when you pump the sand from here, the sand on the coast collapses and falls back down to the seabed. And they keep trying to put it back here. But when you keep doing that, it keeps falling.
This process is currently being used in The Hague to protect the coastline. Some 20 million cubic meters have been pumped to create the equivalent of 256 soccer fields of dunes and beaches. This project is called the Dune Delta. The sand motor technology may eventually prove to be harmful to the country and its inhabitants. By constantly having to find solutions to the problem of living in inhospitable territory, the Dutch could end up having to leave this land. Perhaps the solution for staying safe in Amsterdam actually involves living on the water instead. The latest architectural creation is these floating houses in the Ischberg district on the outskirts of Amsterdam. This suburb is composed of 7 artificial islands and houses that float.
We see it as a technical solution, which is very safe. It has the exact same comfort and aspects as a normal house. The only thing, sometimes we call it a boat because of regulations, and sometimes we call it a house of regulations. So we think about more flexible cities. How can we use the water to be responsive, to react on everything that's happening around you, to be ready for an unexpected future?
For the moment, these floating homes are among architects' preferred means of adapting to the rising water levels that are one of the biggest challenges currently facing the country. The houses are supported by floating concrete tanks immersed in the water. The rest of the construction is made of light steel and wooden panels, which allow for a traditional layout inside. The houses are anchored to the bottom of the lake with steel mooring posts to stop them drifting. But here again, there is a flip side that must be taken into account. Behind this idyllic image of life on the water, these floating houses are already posing some ecological problems. As always, technological innovation disrupts ecosystems. These houses resting on concrete tanks make the water surface opaque. This lack of light causes aquatic life to die. Faced with this new problem, engineers and architects have had to propose new solutions, such as houses on stilts.
The most important thing is that if we start building on water, it's not architecture above the water, but it's architecture also underneath the water. We call this blue habitats. And if I go to a city, the first question they ask, what is the effect on the ecology, on the water system? So we build artificial corals underneath it. We bring enough water, light and air in it. And by that we can influence the system. That means that if you're in the middle of a river or the middle of a sea, we can create these buildings and they start to be as catalyst functions for creating new ecosystems around it.
But is this floating home solution enough to cope with the major upheavals awaiting the Netherlands? In 100 years, entire regions of the Netherlands will most likely be wiped off the map due to rising sea levels caused by melting glaciers combined with coastal erosion and land subsidence. The entire western facade of the country, as well as the inland areas to the south and west of Amsterdam, could be completely erased and submerged by water. Despite all their inventiveness and technicality, the Dutch may no longer be able to find land for shelter.
Living in such a vulnerable country, that means that if there's more water, more climate change, we probably have to leave our country. Because if we do nothing, if we just keep them as it is, if we don't make our levees higher, if we don't find solutions to be floating, then we will be the first to leave.
Float or leave. This is the dilemma caused by climate change that is facing the Dutch. Once again, they will have to come up with an answer, armed with their knowledge of water management.
There are extreme scenarios, and I also believe that then within the country we could do great things. If you think of our response and reconstruction after the Second World War, then a population can do a lot in a short time when the need is there.
And the Dutch are proving this to be true. Right now, a unique project on a gigantic scale is in development. The idea is to build a wall to hold back the sea. It involves a truly colossal dam that would close the North Sea in 2 places. 2 gigantic walls would have to be built in the middle of the sea. The first, some 500 kilometers long, would connect the Scottish coast with Norway. The second, 150 kilometers long, would extend from the southern tip of the UK to the coast of Brittany. This outlandish project would protect 25 million people from the risk of submersion. For the time being, this project is not the subject of a political and economic debate on a European level. It is an alarm bell being rung by Dutch scientists to raise awareness about government inaction on climate change. But once again, the impact of such a construction would be immense. This dam, on an unimaginable scale, would transform the North Sea into a freshwater lake. Such extensive modifications of an existing ecosystem would irreversibly disturb the surrounding ocean currents, including the famous Gulf Stream. It is this ocean current that ensures mild winters across Europe. Without the Gulf Stream, every country in Europe, including the Netherlands, might then experience winters like those enjoyed in Siberia.
The problem is that when you build a wall, you think you're protected. But it's always the same. You carry on expanding, creating, and building behind the wall because you think it's protecting you. And that's what risk management is about. You try to resist and protect yourself. But if the wall or the dike were to be breached, well, you can imagine the scale of the disaster that would ensue.
The risk of a technical failure is huge. One only has to imagine the amount of water that would be held back by these 2 dams. And if a breach were to occur, the flooding of the entire coastline would be a catastrophe for which no one could ever be prepared.
Now, evacuation of, let's say, the region of Rotterdam, The Hague, our capital, and Amsterdam, within 24 hours, it's impossible. Millions of people evacuate out of that area. So the evacuation plan is also to get people to higher ground. So our evacuation is more a vertical evacuation than a horizontal evacuation.
And the first region that might risk being wiped off the map is Flavorland, the suburb of Amsterdam. This immense polder, this land reclaimed from the sea, is today the area most at risk. 400,000 people live and work here, a population comparable to that of Manchester or Miami. It is absolutely necessary to ensure its safety.
It's not a technical problem, it's a societal choice that must be made. And that's the biggest problem for us now. We know that sea levels are going to rise by 2 or 3 meters, but we don't know when. We have to make the right political decisions now, which won't harm us in future. This is our duty.
The example of Flavorland, the newest and most endangered province, is leading the Dutch to change their attitudes. At a time of climate change, a new environmental consciousness is emerging, encouraging them to give up on the idea of more growth.
Today's society values the natural system and nature much more, and is hence in favor of leaving it as it is.
We have to listen to nature, we have to live with water, and we have to follow nature, and then see what we can do with that. Only fight against it, that doesn't work anymore. We should understand what the water is doing, what nature is doing, and then make the best of it.
The time has come to return artificially created land to the sea. Depolderisation is the new choice of the Dutch authorities to protect the country from danger. Reclaiming land, this practice that has been carried out for centuries, has, under the effect of climate change, had a negative effect. Hiding behind a dike, there is a growing awareness of the risks.
But I also think that on schools they don't teach the students enough how this country works. Because if you would talk to just somebody here on the street, they say, yes, we know we have polders and we know we live below sea level, but they don't know that it is an active system. If you're not pumping water out, we will drown.
Avoiding ending up underwater has been the challenge facing the Dutch since the Middle Ages, with their incredible engineers and the most sophisticated anti-flood systems in the world. Today, this country, whose coastlines look like lace spread across the North Sea, finds itself at a turning point for its very survival. Global warming is causing sea levels to rise relentlessly. So how could we have imagined that the storm of 1953, as violent as it was, could today be 3 times more destructive, and that next time it could well reach Amsterdam? Will the Maasvlakte-Kering and the Hartelkering barriers have to close more often in the coming years? Will the Oosterschedelkering, which some call the 8th wonder of the world, with its 35-metre-high pillars weighing 18,000 tons each, still be able to hold back a sudden rise in the North Sea? If the water rises more than 10 metres, what will become of the Afsluitdijk, the Enclosure Dam created at the beginning of the 20th century, which was considered to be a model of safety? 1 degree, 2, or even 3.5? How much temperatures will rise is the great unknown. The entire system underpinning this country could collapse like a series of dominoes if the temperature rises. In the end, there is no technological prowess that can ever withstand the full force of nature.